Hi students, today we are discussing about 17th group, that means 7th year group elements. You know the 17th group elements we call halogens. So the location of halogens is important. You know the periodic table, the right side of the elements, the location of halogens are right side. You see the location, they are fluorine and chlorine, bromine, iodine and astatine. These group elements are called halogens. This is the location of right side of the periodic table. The differentiating electron, the halogens enter into p block. That's why the halogens are we called p block elements. ఓకేనా, భేదపరిచే ఎలక్ట్రాన్ p ఆర్బిటాల్లోకి వెళ్తుంది కాబట్టి ఈ మూలకాలను p బ్లాక్ మూలకాలు అంటారు. సో మన సెమిస్టర్ ఈ సిలబస్లో ఈ గ్రూప్లో ఎస్పెషల్లీ ఇంటర్ హాలోజన్స్, సూడో హాలోజన్స్ అండ్ పాలీహాలైడ్స్ అనే దాని మీద మన సిలబస్లో ఉంది. సో బిఫోర్ గోయింగ్ టు ఇంటర్ హాలోజన్స్ వీఆర్ డిస్కసింగ్ అబౌట్ ద ఆల్ 7th year group elements information. So first of all, the location of halogens are clear. The right side, they are belongs to p block elements because of the differentiating electron into p orbitals. There are 5 elements, you know the fluorine, chlorine, bromine and iodine, astatine. So the 5 elements we called generally common. Out of the 5, the first 4 elements are called halogens, denoted by X. So the halogens are diatomic molecules. So the stable form is diatomic state. So the atomicity is 2. Therefore, generally we denoted by X2. X means halogen. X2 means it is a diatomic state. The best example, X2 is equal to F2, Cl2, Br2 and I2. The last element astatine is a monoatomic state and it is a radioactive element. So out of the 5 elements, the first, they are all non-metals and fluorine and chlorine are gases and bromine is a liquid and iodine, astatine is a solids. The physical state you see, you observed from top to bottom, the first 2 are gases, the next one is liquid, bromine liquid and remaining 2 are solids. Okay, so all are non-metals and the physical state also clear. Now the next one is atomicity. They are all diatomic state, right? And now the another important is the electronic configuration. You see, this is electronic configuration. The fluorine atomic number 9, the electron configuration 2s2 2p5. The next element 3s2 3p5. The next element 4s2 4p5. So the overall, the common electron configuration is ns2 np5. You remember the common general electronic configuration of halogens are ns2 np5, right? So based on the electronic configuration, we can explain the oxidation state. The common electron configuration is ns2 np5. So 7 valency electrons are present here. For going to octet configuration, they need one more electron. వీటికి ఆల్రెడీ 7 ఎలక్ట్రాన్స్ ఉన్నాయి. ఒకే ఒక ఎలక్ట్రాన్ అవసరము ఫర్ గోయింగ్ టు నోబుల్ గ్యాస్ ఎలక్ట్రాన్ కాన్ఫిగరేషన్. సో దట్స్ వై దే నీడ్ 1 ఎలక్ట్రాన్. Okay, so they need 1 electron. So the all elements, they shows -1 oxidation state. సో అందుకనే హాలోజన్ మూలకాలన్నీ కూడా -1 అనే కామన్ ఆక్సీకరణ సంఖ్యను ప్రదర్శిస్తాయి. సో వై? బికాస్ ఆల్రెడీ 7 electrons are available on central atom. They need 1 electron only. So that's why all are exhibiting -1 oxidation state. Except fluorine, because of due to small atomic size, not available the vacant d orbitals, they shows only -1 oxidation state. You come to chlorine, bromine, iodine. They are big size elements. They are available in vacant d orbitals are available in these 3 elements. That's why these 3 elements shows not only -1, they are showing +1, +3, +5, +7 oxidation states. So you remember only fluorine -1, but the remaining 3 elements shows +1, +3, +5, +7. So astatine is a radioactive element. It is not stable, it is unstable. So this is the information about the oxidation state of 7th year group elements halogens. And now the property physical state is completed and oxidation state also be discussed. Atomicity already discussed, it is a diatomic state, and electronegativity. So entire periodic table, the 7th year group elements, the halogens are shows or exhibit more electronegativity, because highly electronegative elements are available in 7th A. So therefore, in entire periodic table, according to group wise, the 7th A comes first. According to element wise in the 7th A, the fluorine exhibit highest electronegativity. Highest electronegativity according to Pauling scale, the fluorine value is 4.0. The second highest electronegativity is oxygen, 3.6 value. The third highest nitrogen, 3.1. The fourth highest electronegative element is chlorine, 3.0 according to Pauling scale. According to Pauling scale, the fluorine position comes first. So that's why in entire periodic table, the fluorine is exhibit highest electronegativity. So this is the important point for competitive examination point of view. Right. And second one, the group wise 7th A, element wise fluorine. Right, clear. Now come to the next property is electron affinity. Affinity means attraction towards nucleus side. So the 7th A group element highly already electronegative elements. They need only 1 electron only. That's why the easily the electron capturing these elements. That's why the electron affinity also they are exhibiting highest values. Out of the all groups, the 7th A group elements are exhibiting highest electron affinity value. Okay, from fluorine to iodine, the chlorine exhibiting highest electron affinity value. Actually, fluorine ఎక్కువగా ఉండాలి, ఎందుకంటే ఫ్లోరిన్ ఎలక్ట్రోనెగటివిటీ ఎక్కువ, ఎలక్ట్రాన్ ఎఫినిటీ దానికి ఉండాలి, మోర్ అట్రాక్ట్ అవుతుంది, చేస్తుంది, ఈజీగా క్యాప్చర్ చేస్తుంది. కానీ ఇట్ ఈజ్ ఏ స్మాల్ సైజ్ అండ్ అరౌండ్ స్మాల్ సైజ్ ఫ్లోరిన్ more lone pairs are present here. Due to lone pair repulsions, the electron not easily towards nucleus side. So comparatively fluorine, the next element is chlorine. That's why the chlorine atom exhibiting more electron affinity value. Right. So the first one, electronegativity, the first goes to fluorine. Electron affinity, the first goes to chlorine. So you remember these 2 points are very, very important for examination point of view. ఆవర్తన పట్టికలోనే అత్యధిక ఎలక్ట్రాన్ ఎఫినిటీ గల మూలకం ఏది అంటాడు క్వశ్చన్. విచ్ ఎలిమెంట్ కెన్ ఎగ్జిబిట్ హైయెస్ట్ ఎలక్ట్రోనెగటివిటీ, దట్ ఈస్ కాల్డ్ ఫ్లోరిన్. ఇన్ ఎంటైర్ పీరియాడిక్ టేబుల్ ఎలిమెంట్స్, విచ్ ఎలిమెంట్ షోస్ ఆర్ ఎగ్జిబిట్ మోర్ ఎలక్ట్రాన్ ఎఫినిటీ, దట్ ఈస్ కాల్డ్ chlorine. Okay, these 2 points are very, very important. And oxidizing power, so the fluorine is a more oxidizing power, the fluorine to fluorine, the first one, the next chlorine, next bromine, and the least one is iodine. the oxidizing power decreases from fluorine to iodine. So why? Because the fluorine is a small size and more electronegativity, easily involving all chemical reactions. That's why the fluorine generally we call super halogen. దీని సాధారణంగా దీని యాక్టివిటీ ఎక్కువ ఉండడం వల్ల దీన్ని మనం సూపర్ హాలోజన్ అని అంటాం. మెల్టింగ్ పాయింట్ అండ్ బాయిలింగ్ పాయింట్ ఆల్సో. The fluorine F2, you see the boiling point, melting point value, these are all the boiling point, melting point values of halogens, fluorine, chlorine, bromine, and iodine. And here the fluorine is a liquid gas state and chlorine also gas, bromine is a liquid and iodine is a solid. That's why the boiling point value 185 Celsius. And this is the bond energy value. This is also very important, bond energy. The F2 molecule, the bond dissociation energy, you see 126 kilojoules, and chlorine 210 kilojoules, and bromine 158, and iodine and 118. So out of the four, the highest bond energy value shows that is one is chlorine. So why the fluorine exhibiting less bond energy value? Okay, actually according to theoretically, the fluorine comes first, అది ముందు ఉండాలి. The fluorine is a small size, more attraction between two fluorine atoms. So then dissociate చేయాలంటే we have to provide more energy ఇవ్వాలి comparatively chlorine and bromine, iodine. But according to experimental value, the chlorine comes first. Chlorine ముందుగా వస్తుంది. సో మరి ఎందుకు ఫ్లోరిన్ తగ్గిందంటే the reason is the fluorine is a small atomic size comparatively chlorine bromine, and in between two fluorine atoms, each fluorine having 3 lone pairs. Due to small size and more lone pairs, the repulsions between lone pair, the bond in between two fluorines weaken. So bond weak avutundi. So that's why normally we have to provide the less energy, automatically the fluorine molecule convert into fluorine atoms. So the bond energy value decreases comparatively chlorine and other elements. So this is the information about bond dissociation energy. Right. The next one is chemical properties of 7th A or halogens. So after physical properties, you come to chemical properties. The chemical properties, here 6 types of properties are there. The one is hydride, the second one is oxides, and third one is oxyacids, and fourth one is interhalogens, and next one pseudohalogens, and the last one is the polyhalates. According to the above, in our syllabus, the interhalogens and pseudohalogens, polyhalates are very important in our semester syllabus. But before going to that, what is hydrate, what is oxides, and what are the oxyacids we are discussing. So in previous class I told you already, the hydrates means the group elements react with the hydrogen gives hydrates. So for example, the 7th A group elements denoted by X, the X interact with hydrogen gives HX formula of hydrates. In place of X, you have to substitute fluorine, chlorine, bromine, iodine, you are getting HF, HCl, HBr and HI. So these are the hydrates of 7th A group elements. So the HF is available in liquid state due to intermolecular hydrogen bond. So hydrogen bond వల్ల HF అనేది liquid గా ఉంటుంది. You come to HCl is a gas, remaining are liquids. Right. So the HX formula, generally the central atom is X, around X the 7 valence electrons are there. Okay. So out of the odd electron interact with the hydrogen gives a sigma bond, and around X 1 sigma and 3 lone pairs are there. 3 plus 1 4. 4 means the all hydrates of halogens shows sp3 hybridization and geometry is linear because 3 lone pairs are present around the central atom. Only 1 sigma bond is there. That's why the geometry is linear and hybridization is sp3, and number of lone pairs are 3 lone pairs and 1 sigma bond. So this is the information about hydrates. And the next one is oxides. So the 7th A group elements, the halogens are react with oxygen gives 4 types of oxides. So, the oxides means the elements react with oxygen. Suppose you take fluorine, when react with oxygen gives only 2 types of oxide. One is fluorine monoxide and second one is fluorine dioxide. So, OF2, O2F2, right? These 2 oxides. Except fluorine, you come to fluorine, bromine, iodine. These 3 elements when react with oxygen, they gives 4 types of oxides. One is chlorine monoxide, Cl2O. Second one, chlorine dioxide, ClO2. And third one, chlorine hexoxide, Cl2O6. And fourth one, chlorine heptoxide, Cl2O7. Like this, bromine and iodine also, they give more types of oxides. Suppose you take the chlorine oxides, Cl2O, ClO2, Cl2O7, O6 and O7, the 4 oxides, when dissolved in water, they produced acids. That's why the 4 oxides are generally we call acidic oxides. Acidic means they produce acids when dissolved in water, right? The Cl2O, when dissolved in water, they are producing hypochlorous acid, and ClO2 gives chlorous acid, and Cl2O6 gives chloric acid, and Cl2O7 gives perchloric acid. So, that's why these are the chlorine oxides, and iodine also, iodine pentoxide, iodine heptoxide, iodine monoxide also there, and bromine also, bromine monoxide, dioxide, tetroxide, like this. So, these are all the oxides of halogens. All are acidic nature, right? Clear. Now, come to oxyacid. Just now I told you the oxyacid means the group oxides, the element oxides, when dissolved in water, they are producing oxyacids. For example, you take chlorine. The chlorine oxides are 4, Cl2O, ClO2, Cl2O6, O7. These 4 oxides when dissolved in water, we are getting 4 oxyacids. One is HOCl, hypochlorous acid, and second one chlorous acid, HClO2, and third one chloric acid, HClO3, and fourth one HClO4 for chloric acids. These 4 are oxyacids of chlorine. Same way bromine and iodine also they can form oxyacids of bromine, oxyacids of iodine, right? But in case of fluorine, they have only 2 oxides, but they can produce only 1 oxyacid, that is called HOF, hypofluorous acid. But the remaining all elements of halogens, they give different oxyacids, right? So, this is the oxyacids of, like this you see the formula, the general formula, oxyacids of halogen HOX, HXO2, HXO3 and HXO4, right? So, this HOX means hypohalous and halous, halic and feralic acids. The oxyacids of halogens, the formula are 4 types. So, one is HOX and the second one HXO2 and HXO3 and HXO4, right? In place of X, you have to substitute chlorine, bromine, iodine, we are getting 4 types of oxyacids. Okay. Now, the oxyacids of chlorine, just now I told you HOCl, HClO2, HClO3 and HClO4. For example, you take HOCl, the central atom is a chlorine, the chlorine containing only one OH group is there, that is why it is a monobasic acid. The anion is OCl minus, hypochlorite ion. You take second one chlorous acid HClO2, this chlorine containing one monobasic, it is also monobasic acid, one OH group is there, and the anion is ClO2 minus. This is called chloride ion, hypochlorite and chloride ion. And third one is the formula is HClO3, chloric acid, the anion is ClO3 minus chlorite, okay, and chlorate ion, and the last one is HClO4 for chloric acid, the anion is ClO4 minus, this is called perchlorate anion. Suppose you take us acids, the corresponding anion is called ite. If you take ic acids, the corresponding anion is called ate. Suppose you take chlorus, gives chlorite anion. You take chloric acid, gives chlorate anion. So, Us gives ite anion and ic acids gives ate anion. So, this concept is very important for the classification of acids. And now these are the oxy acids. In the chlorine, all oxy acids, the central chlorine atom exhibiting sp3 hybridization. Suppose you take the first chlorine oxy acid, hypochlorous acid, the chlorine atom containing 1 sigma 3 lone pairs, and second oxy acids of chlorine, chlorous acid containing 2 sigma 2 lone pairs, and third acid, the central atom containing 3 sigma 1 lone pair, and fourth oxy acids, furchloric acid, the chlorine atom containing 0 lone pairs, 4 sigma bonds, right. So, the first one, second one, third one, fourth one, all are having sp3 hybridization, but the geometry is changed from first one to last one. The first one geometry is linear, and second one geometry is V shape, and third one geometry is pyramidal, and fourth one is tetrahedral. So, hybridization is the same, but the geometry is changed from top to bottom. The due to the reason is lone pair repulsions around the central atom. So, that is the most important here. sp3 linear, second one sp3 V shape, the third one sp3 pyramidal, and fourth one sp3 tetrahedral, right. The first one 1 sigma 3 lone pair, and second one 2 sigma 2 lone pair, and third one 3 sigma 1 lone pair, and fourth one 4 sigma 0 lone pair. Overall hybridization is sp3, the geometry is changed, right. So, this is the outlines, the information about the oxy acids of chlorine, right. So, the oxy acids out of the 4, the first last acid hypochlorous acid. So, strong electron withdrawing groups are present around the central atom, the 4 oxygen atoms. Out of the 4 oxygens, the 3 oxygen bonding with the double bond, highly electronegative oxygen atoms are there around central. So, more electron withdrawing groups are present around the chlorine atom. So, that is due to more electron withdrawing group, the easily the hydrogen replaced here. So, easily H plus replace చేస్తుంది ఇస్తుంది, leaving the H plus ion. That is why in entire periodic table, the HClO4 furchloric acid is the strongest acid among the all acids in periodic table. So, ఆవర్తన పట్టికలో లోని అన్ని ఆక్సి ఆమ్లాలలో బలమైన ఆమ్లం ఏది అంటే hypochlorous acid is belongs to 7th A, is belongs to chlorine. ఓకేనా. సో, క్లోరిన్ ఆక్సి ఆమ్లాలలో ఈ ఆమ్లానికి బలమైన ఆక్సిడైజింగ్ పవర్ ఉంటుంది, బికాస్ ఆఫ్ ద క్లోరిన్ హ్యావింగ్ 4 strong electron withdrawing group oxygen atoms are present around the central chlorine. That is the reason, right. So, the oxidizing power or acidic power decreases from 4th one to 1st one. Who is the 4th one? HClO4 is a powerful. Next HClO3, and the least HClO2, and the అన్నిటికంటే least HOCl, hypochlorous acid is the least energy power, and topmost power goes to HClO4. So, this is the order of the acidity, decreasing order of the acidic power or oxidizing power, right. So, this is the information about oxy acid. These are the structures of oxy acids of chlorine structures, and the next one iodine oxy acid, same way like this chlorine. And now the most important one is interhalogens. So, this is the actual our syllabus, the interhalogen. And previous class I told you halogens, halides. Halides means the group element when react with the halogen gives halides. Any group element in the periodic table react with 7th group elements like fluorine, chlorine, bromine, they gives different halides. But in case of 7th A, already they are halogens. The halogen, one type of halogen react with another halogen, gives this type of compounds are called interhalogens. Inter means the same halogens, same group of halogens, they interact with each other, they give interhalogens. The definition is each halogen can be combined with other halogen to form several compounds. These are known as interhalogen. Basically, the interhalogens are 4 types. Very important for examination point of view. The classification of interhalogens are important. One is AX type, AX3 type, AX5 type and AX7 type. These are the 4 types we can classify. The interhalogens definition and classification completed. Now we are going to one by one. First you take AX type. Okay, AX type. Before going to that, the properties of interhalogens also very important. So all interhalogens, for example, the example you see the AX type. Best example CLF. AX3 second type, the best example CLF3 or BRF3, ICL3. You take third one AX5, okay, IF5, BRF5. Last model AX7 only iodine IF7, right. So these are the examples of interhalogens. And now come to properties. All interhalogens are volatile gases and easily evaporated gases, and some are unstable and but more explosive, right, easily explosive nature. The most of the interhalogens are covalent nature, not ionic, the covalent nature. And due to ionization, the interhalogens in molten state conduct electricity. The interhalogens on dissociation gives different ions are formed here. That's why they are exhibiting, they shows electric energy also, electric conductivity also. And some interhalogens act as a non-aqueous ionizing solvents. So some of the interhalogens are acting as a solvent molecules. And one more important here, on reaction with water. This is the most important for coming examination point of view. Any interhalogens, when they interact with water, they gives 2 types of acids. One is hydroacid and second one is oxyacids, right. Suppose you take ICl, iodine chloride, it is one of the first type of interhalogen. When react with water, they gives 2 acids. One is hydro HCl, the second one oxy HOI. Suppose in ICl, the chlorine is exhibiting a more electronegativity. The more electronegativity halogen gives hydro, the less oxidation electronegativity halogen gives oxy, right. So the ICl will react with H2O gives HCl and HOI. You take second example BRF3. Out of these 2, the fluorine is more electronegative, bromine is a less electronegativity. The more electronegative halogen gives hydro and less electronegative halogen gives oxy. Therefore, we are getting HF and HBrO3. IF7 plus water gives HF plus H3IO5. Like this. These are all the hydrolysis reactions are very important. And the next structural information of interhalogens. Okay. So first of all, the definition of interhalogen completed, right, and the classification of interhalogen completed, and the next one, the properties of interhalogen also completed. And before going to that, when we are going to interhalogen structures, the first of all recall of our today our class, the first one, what is the location of 7th year group elements and the group elements, the properties of 7th year group elements, whether it is physical property or chemical property. The physical properties are mainly atomicity and electron affinity and electronic configurations clear, and then the other properties also completed. Then go to the chemical properties of hydrates, the types of hydrates and properties of hydrates, the structure of hydrates also clear, and then go to the next one, oxides, the classification of oxides completed, whether it is the fluorine oxides and other chlorine bromine oxides also completed. And the next one, oxy acids of chlorine clear, we have studied about oxy acids of chlorine and oxy acids of bromine and iodine also completed. So, this is the overall information of 7th year group elements, and the interhalogens, the definition of interhalogen just now you seen, and the classification of oxides also completed, and properties of interhalogens also completed, and the next one is the structures of interhalogens. The further next class we will discuss about the structures of interhalogens. Thank you.